Alright, today we have a U5000 that was sent in. I have the box flipped over because the other side has the person's information on the label. So we're going to open from the bottom here. I just want to do a little unboxing here on camera. Anyway, so we have a U5000 that the whole bottom right corner where you plug in the video input is, I guess, busted off due to bad shipping. Whoever shipped this to the person that sent it to me, from what I understand, had bad shipping and it broke the whole corner off. So they asked if I could take a look and see if I could possibly get this fixed up, and also rebuild it and all that jazz as well. So let's go ahead and open it up and see what the damage looks like. World this just used for packaging. Oh, well, I can't say I've ever seen that before, but that's cool. Okay, well, oh, and what is this in here? A screw? A little tiny screw. Little tiny screw. All right, well, I guess I'll set that aside and pull this out of here. Oh, and it's dirty. Guess I'll have to wash it. And you guys will have to wait. Not very long, but for me, oh man, it'll be quick. And holy, wow. I'd say that's a problem. Yikes. This may be a more complicated repair than I expected. And of course, like every one of these that ever gets shipped to me, this is all the linearity coil. Horizontal linearity coil is all foobarred on every one of these that gets whacked and, you know, things like that. But a little bit of twisting and bending, we can glue that back in place and you'll never know it was loose. So we'll take care of that. The B+ pot has been replaced with a different type. There's a 3 on here for some reason. R104 is kind of bent out of the way. Okay, and other, it looks like the caps have been, some caps have been replaced, because this one is not. But this one has, and this one has, and that one. Some caps have been changed, like they changed this one, but not that one. So this must have been worked on by P&L or something. But anyway, you can see here, if it wasn't immediately obvious with the dual resolution video header there, we have WGM, as well as Gardner monitors. 2550 is 25-inch U5000. That's how you can identify these. Oh man, R765 here is burnt. Let's see if you can tell that there is completely burnt. So I think that's 760 and 765. I could have those backwards, but that one's roasted. So our HOT, I don't even know if it's not even the right kind. It's a NTE 2324. Is that even compatible? I don't know. We'll find out. And then that corner that's busted off is right here. And it's not busted off, it's just broken. Right there. I don't recall this being mentioned in the conversation with the owner of this, but that's bad. Wow. Now let's go ahead and flip this over and see what the back side looks. Oh, ho, ho, ho. I don't know if this is going to be fixable. This might be my greatest triumph to date if I can get this working, but yeah. Crazy. I think that's due to a bad solder joint. is probably what happened there. But holy crap, both sides are completely roasted. Wow. Fixing this down here shouldn't be that big of a problem. But holy crap, that's insane. I've never seen that happen before on one of these. Wow. And this up here is completely burned up too. What happened here? I think maybe, oh, we got this right there. It doesn't look very good. I think maybe this might have slid over. This was in the frame, and it might have not have been secured, you know, with the two mounting holes, and it might have just kind of slipped out of the frame and touched the ground or something. I'll bet you that's what happened. But wow, so we got this whole corner burned up. This corner's broken. R760, I believe, is the top one. That's completely roasted. The solder joints are destroyed. Different B+ pot, whatever this 3 means. What else was there? The hodgepodge of replacement caps. Oh man, so I think I can wash it. It's not so dirty that I can't work on it now. I think I'll wash it afterward so we can let it sit and I'll send it back. This resistor here has been replaced. That's not original. I think that's R728. Yeah, this is burned up and someone has replaced it in the past. And the solder joints are loose, or at least the top one is here. This one is loose. Man, this is going to test all of my ability here to get this one fixed. So it's not so bad that I can't work on it without washing it first, but we're going to have to end up washing it. The neck board, I'm just going to disconnect this here so we can separate it. He says, not knowing how difficult this connector is on. Wow, okay. Take that off and lift that and pull this out. Okay, now we can set this aside. And as far as the neck board goes, it has not been butchered. Looks like someone's replaced this transistor, but it hasn't been butchered, and we can fix it to where all of these sit straight. And there we go. I can fix it better later, but okay, not going to be too worried about this. This is going to be our tackle here. Now, part of this procedure on these, I always also extract all these pins because you can see how burned up these are. This ground jumper here, you can see how burned up this gets. So it's always a good idea to push the little locking tab in, pull the pin out, clean the pin with your fiberglass scratch pen, get all the oxidation and corrosion off of there, and then you can reinstall it. So I do that on all of these pins. Highly recommend that. I also recommend using your fiberglass pen and cleaning these pins too. If you see here, this connects, and it actually connects and touches and contacts the outside of the pin, not the inside of the pin. So all you have to do is clean this outside. So get the oxidation off of these pins on both of these connectors using your fiberglass pen. And then after you clean these pins, this is more reliable of a connection too. So, and someone's already gone through and reflowed these header pins for that's a common issue on these as well. But man, I think we'll have to start with doing our light bulb test and testing our power supplies section. Okay. Oh man, red header pin's bent way out. I'm going to disconnect our remote board harness, set that aside. And now we have the whole chassis here, and I'm going to get rid of this number 3 identification sticker. I'll stick it back on when I send it back. Okay, what do we want to work on first here? So I'm going to turn my fan on. Oh man, okay. So I guess what we can do is we'll measure R104 and make sure it reads 10K. If it reads 10K, then there shouldn't be any unknown anomalies with passive components unless there's a shorted diode or something else. But that normally when there's a shorted diode somewhere or there's an open resistor, this reads kind of out of whack. So if R104 reads 10K, 10 to 13 is about the range they normally read. It's supposed to be 10K, but it can read up to 13K and the system will still function. Then our power supply should be okay. So we'll have to test that first. This W158 jumper right here, we can remove this side of the W158 jumper, and that will isolate our power supply from the rest of our chassis, I should say our horizontal output side. And let's get a better eye on that. That's right here. Okay, and we can lift that out of there. Okay, that's extracted. Now we can test R104. We'll get our meter, and it should read about 10K, give or take, and it reads 9.3K. That's fine. And let's give a look over here before we go getting ahead of ourselves. And I don't see quite anything too wild here, so we do need to reflow the power input joints here. Okay. All right, well, with that done, let's get ourselves our 60-watt incandescent bulb, and we'll hook one lead to ground, other lead to this W158 jumper. Let's grab our meter, put it on volts DC, and we'll grab a couple of leads here. Positive goes to this same jumper. Negative will go to the same ground. The vertical IC heatsink will do just quite nicely. All right, well, I'm going to turn this on. As soon as I hook up power here. Okay. And hopefully it turns on, we get good B+. We're going to adjust the B+ to about I'd say 119-ish. I've made the mistake, I think, on the last video where the 60-watt incandescent bulb is a very close analog to the load that the actual CRT will use. But I think I set it to 118.5 last time, which was a little too high. I need to go the opposite way. I forget. We'll just go to like 119, and hopefully that's somewhere around 117 when the actual CRT, because this is a very close analog, but it's not perfect. So I think if you do like 119, it ends up being close to 117, which is what B+ should be on this when you use the actual tube. So we'll go to 119, assuming this works. So let's turn it on here and count to 3. 1, 2, 3. Yes, it works. And we are at 120.5. So I'm going to go down here to about 119. Perfect. Hot dog. Okay, well, at least that's one step in the right direction. That's good. So I'm going to take this all back apart here. And I'm going to put that jumper back in because I always forget. So I didn't want to, I'm glad I don't want to have to troubleshoot a bunch of power supply problems on top of everything else we're going to have to do. So So let's get that jumper back in there. All right. La-dee-dee, la-dee-da, life goes on, blah, la-dee-da-dee, life goes on. All right, and I think I'm just going to remove this connector for now. Okay, so I'll clean that up later. I just don't want it flopping around and having the wires break off. So, okay, man. Oh, wait a minute. Wait a minute. I know what happened. Look at this. This is all burned up here. I'll bet you this thing flung over here and went bzzz, like that. That's what happened. This thing was sitting here. Normally this is supposed to be screwed into, there's a hole here and a hole there, and you screw that in there and bend this out. That's how it's supposed to be. But I think this thing got, you know, just was flopping around in the breeze and went over and went bzzz, right onto there. Because look, that's exactly what happened. Touch that, bzzz, burn that up. Almost guaranteed. Because it won't reach over to there. So, dang, that's what happened. Now, did that take out U701? We're not, I don't know, we'll find out. Actually, you know what? Let's test that. Here, the easy way to do is put your meter in continuity mode. And we can just go to all the pins and make sure no pins read the ground that shouldn't. There should only be one ground pin. So we'll just start here. Nope. $25 ohms. That's not good. $25 ohms. And that runs directly to this capacitor, this little blue capacitor here. And I'm getting ahead of myself by doing all this, but let's test this little film cap here. Little film cap is not shorted. The blue cap is shorted, 25 ohms. So this thing blew open this resistor, shorted this C703 cap. Definitely 25 ohms. So we would need to remove this cap to see if our short goes away that's on our U701. Hopefully it does. I mean, I have a parts board I can steal these parts from. But man, oh man, that's just crazy. And I need to get, bear with me, I'm going to pause here, and I need to take a quick picture for a thumbnail, because I don't want to go through and repair all this and not have like a before picture of the thumbnail. This might be a rather long video, quite honestly. So get yourself some popcorn and we will see what we can do. Let me pause here. I'll take a couple of quick snapshots and I'll come right back. All right, that's done. See, that wasn't so bad. All right, what do we want to tackle first? I guess since our power supply is good, we can tackle, I guess, this here first. So, man, we need to remove this destroyed resistor. She gone. And when you do these kind of repairs, you can't just replace the components. You have to get rid of the carbon too, because the carbon is conductive. So we want to remove that carbon. And I'll put a link to this fiberglass scratch pen that I use down in the description so you can get one for yourself. But they work 1,000 times better than those other cheap, crappy ones that you get that aren't actual real fiberglass. And I just realized just now the B+ test point is missing. Maybe I'm wrong, but I thought the B+ test point is right there, and it looks like that is missing right there. Maybe, oh no, B+ test point's right there. This is where it's at on the 7400, 7500. Okay, yeah, that's just something that when they changed that cap out, they desoldered that and didn't fill it back in. Okay, stop getting distracted. Let's go. Stay on point. So let's clean this up. Oh, it's completely burned off. There's nothing left. There's nothing left here. It's gone. That did a number on that thing. Man. When you're working with real fiberglass, it's important to not get this all over your arms and hands. You want to get it, you know, blow it off or sweep it off as quick and easy as possible. Okay. But as you can see here, that's just destroyed, and there's nothing left here but the trace, which we can just solder a jumper on or something. So that's that. Now let's remove this shorted capacitor. The RCB. And I say shorted capacitor because that's what I'm hoping it is, because if we still read that 25 ohms across the two pads, then it's our U701 that's at fault. And that's not a game ender, but that's unfortunate. So I think what we'll do first is let's go ahead and just test U701 to ground again, and we'll follow this trace that was this one here, right here. Damn it! We'll go to ohms, we'll go back to ground, we'll go to that pin, and 25.4 ohms. Darn it. Let's test the cap. The cap is not shorted. I know you can't see the meter, but let's do it this way. The cap, not shorted. Go to ohms, not shorted. We'll try and do the capacitance here. 2 nanofarad. So this cap, I think, is fine. It's just covered in carbon. Let's clean the top of this now. Dang it! That's a bummer. Holy crap, this thing just destroyed this whole corner. It's one big ground plane, which is why that happened. Okay, that's the rag there was clean, so the carbon is gone, even though it looks black still. But man, that's insane. Okay, well, we can put this cap back in. I'm confident that it's fine. Yeah, it says 152 on it, so with the 2 nanofarad, that's a good reading. And I'll bet you that our U701 is simply faulty. Well, I was going to put the cap back in if it didn't fly off into the 9th dimension. But as per usual, nothing's ever easy. Nope. Well, I'm not sure why it's giving me such difficulties here, but because why wouldn't it? If I was any good at video editing, I'd just speed this whole part up, but I'm not. So watch the video at 1.5 speed if you want. Save yourself some time. These little components are always a nightmare. I can't get this stupid. All right, I've had it. It's time for the big guns. There, I don't want to hear any more complaining out of you. You, I'm talking to you. You, right there. What the hell? All right, hang on. All right, so in the interest of time, I went ahead and finished up this corner here. I got U701 that we suspect is bad being out. Got a socket installed. I got that pesky C703 reinstalled. I don't know why it was giving me such a hard time, but it was. I got that back in there. And R713, this is actually R713 that burned up. I got that replaced from this donor board here. So, yep, right there, R713, and then, of course, C703. This one was still reading okay, so we put it back in. I'm sure it's fine. So with that out of there, let's test and make sure that we're not shorted anymore. So it was the second pin to ground, and as you can see the meter here, nope, no more 25 ohms. And if we check the actual chip itself, pin 4, when it's installed in the board like this, you know, the corner, here is the how do we describe that? The notch to indicate polarity. So pin 4 from the bottom right here, I don't know how this is numbered, but this pin right there is ground. If you go to pin number 2, 25 ohms. This chip, bad. If we grab a spare here, which I've got, I should have already dug out of here, but I got a bunch of them right here. And if we grab 7850, that's it, LA7850. If we grab one of these, which is easier said than done. There we go. I'm sure I'll need something else out of here, so we'll just set that aside for now. we'll grab a good one and we'll do the same thing. This one to here, 25 ohms. This one to here, open. So absolutely, boom, first casualty, U701. So now we can put this back in here, making sure our notch is set properly. I say back in here, I'll put this one in here for the first time. There we go, nice and secure. And let's test it in the chassis. This one to ground, and a horse pin 4, 1, 2, 3, 4 here is ground, and nope, nothing. So I think our destroyed corner over here is now back in working order, but I notice now that this is loose, and it's not even soldered in. The solder joint is broken. If you look here, right here, right there, you can see that it's not even soldered in. So I'm going to do a recap anyway, but you know, I might want to, I'm going to power it up with the caps in here that are in here just to see what it does. So let's fix that. Fixed. Nope, you couldn't see it, sorry. I soldered that leg back on there, so this isn't wobbly anymore. Okay. Out of just pure curiosity, I want to see what it does. After we fix this to where there's no more issues, I want to power it up with the original caps here. Well, the ones here that haven't been replaced, and see what it does. This one is loose too. Ever so slightly. And that one is not one of the ones that has been changed. But I'm gonna reflow this anyway here. Okay. Alright, well this is now fixed. As a matter of fact, I think I forgot to show it. So with that giant opening there, I was able to actually push the resistor in a little bit more and gain a little bit more length on the leg, and was actually able to solder the leg directly to this trace without having to put a jumper wire in or a bodge wire. So I actually just soldered the leg goes all the way to roughly there, and I was able to solder it right to that exposed trace that I exposed there. So as you see, nothing's touching, and that goes right over here to where it's supposed to go. So that's all fixed and should work just fine. So now I guess we'll concentrate on R760 and R765 here. These guys. Let's get this. It just comes right out. It's black. I just pulled it out without even desoldering anything. And it's about to break off. This leg is charged something awful. But out of curiosity, I wonder what it's supposed to read. So I think, is it? Okay, so 760 is the top one, and 765 is the bottom one. I think that's what I said. No, I might have referred to this one as 765 though. Either way, 765 is the bottom one, and 760 is the top one. 760 is the top one, and 765 is this bottom one here. I've already been robbed from this one, but I'm pretty sure it's supposed to be between 100 and 500 ohms for 765 and 33K for 760. So this one, I think this one actually is supposed to be 33K maybe. Just curious what it reads, if I can get any reading on it at all. Well, that's 700K. That's not, regardless, that's not right. Let's see what 765 reads. That's not right either. Not even close. So it's supposed to be 33K and then between 100 and 500 ohms depending on the revision of the 5000. Whichever revision you have, it's supposed to be between 100 and 500. Now, I think this one is supposed to be, I think R765 is supposed to be the 100 to 500. I could have it backwards, but regardless, it's supposed to be 100 to 500 or 33K. That's what these two should read. And you can see that this one is neither. It's 3K. That's not right. This one was 700K. That's not right. So these are both bad, which you have to start suspecting. There's a Zener diode here that's all charred. I'll probably have to replace that because it looks like this leg's about to break. So there's a Zener diode there that's bad. Then there's 760, 765. I'll bet you this, I think this is Q803. 708. Q708 I'll bet you is probably shorted. That's this one here. So I'll have to find one of those. I don't think I have any more parts U5000s, but so we got to change 765, 760, whatever this diode is, and then Q708. That diode I have on here, that diode is Z705. Z for Zener. It should be ZD705, but okay. So let's remove R765 and check it out of circuit. It should read correctly in circuit, but we'll take it out anyway because maybe there's something else wrong. Man, this is all burned up. Crazy. All right, so that should come out of there. Now let's desolder Q708. I'm not even sure how this could happen. Unless it's just the bad solder joints caused, just caused this. Well, it could be this thing arcing over here caused it, but so there's 708 out, 760. This thing doesn't want to egress. It'll egress now, though, damn it. There we go. Now let's test 765 here out of circuit. 15K. Well, that's not right. So let's test Q708 out of sheer curiosity. I got phlegm in my throat and I can't get the phlegm out of there. Sorry about that, but let's see what this shows. Uh-oh, resistor. Called it. This is likely what burned up and caused those resistors to go out. So, turn it around the other way, test it again. Resistor, both ways now. So, absolutely, no doubt about that. Called that before we even tested it. Okay. So let's get this Zener diode out of here now too. And that is here. Man, the solder is so oxidized it won't even suck up into the braid. So we'll add some fresh solder, a trick of the trade. There we go. And that whole trace there is lifted off the board. Wow. I've never seen a complete intact. This is crazy. The whole thing here is intact, but there. Well, I'm gonna just cut this. And here it is. Look at this. You ever seen anything like this? The whole thing is there. Wow. Let's make sure not to lose that because we can reuse it. But there you go. So I'm going to go on a hunting mission here and try and locate some replacement parts here. I got nothing coming off on the rag there, so that should be okay. The rest of this stuff seems fine. But man, just roasted, toasted, and burnt to a crisp. Alright, so that diode's fine. This one, fine. Alright, just wanted to check those. Okay, I'll go on some more parts hunting missions and try and find all replacements for those. If that's all good, then we can worry about this crack down here, get that fixed, and then maybe we might be at a point where we can test it. I think so. I gotta clean all this stuff up too that I talked about. I'll just do all that off camera. I've shown that before. But let's test this HOT also, because usually the HOT is a victim of this same explosion stuff. But let's see here. Nope. Wow, HOT is good. Well, okay. Color me surprised. And of course we need reflow, like this resistor here's got burned joints, and it's usually this one, and this one get burned up joints. But someone's reflowed that one. I'll reflow that one a little later, but yeah, I'm not sure. This probably burned up too at some point in the past, and they fixed it with that. Was that 1K ohm? Is that even what it's supposed to be? I know you can't see the meter, but yeah, it's 1K. I think that's right. I'll verify. But okay, let me find some replacement parts, come back, and I'll have them installed, and I'll show the repair, and we'll move on from there. Okay, so this whole area is now repaired. It's a bit of a Frankenstein project, but I'll explain that shortly. So I did get this installed with the screw and a washer like it's supposed to be. It's nice and secure. There's nothing touching. It's all good to go. I also noticed that this was set to medium res, but they had the little jumper plug here set to standard res. So there is a little jumper plug on the U5000 for your resolution setting. When you have it on standard res, you want to hook up this pin to the white wire. So if you look here, there's two connections. You want to hook up that pin to the white wire like so. Now if you're using medium res, you want to move this over to the empty pin like this. But this was on the standard res setting when they had it on the medium res connection, so that could have very well caused issues as well. So we're tested on medium res, so I'll put it back on the empty pin there like so, and you can see the pin there's on the empty pin with no wire, and we'll leave it like that for now. So that's all taken care of. So now we have to get back to this. So if you recall, oh, I also replaced this. It is a 1K resistor, that's correct. So I went ahead and put the correct typing, reading, and wattage in there. Reading and wattage in there. I took that original one that was in here out. It'll work, but I wanted to have a more modern, correct equivalent in there. So that's done. Now to this. So I replaced the Z. What was it? I forget. I replaced the Zener diode. I replaced Q703. 708. Q708. Yeah, Q708, which by the way is the same transistor that's in the Q10 position on the K7000. It is Charlie 2482. Charlie 2482. Same exact transistor that is located in Q10. Let's see, Q10 of the K7000. So if you have a spare K7000 floating around that's a parts board, you can steal Q708 out of that same transistor. So that's changed out. The Zener dial is changed out. R765 is replaced. A little bit of a Frankenstein deal, which I'll show shortly. And R760 is replaced. So R760 is the one here. And it's supposed to read between 100 and 500 ohms. I think I got one that's 400. And then this one here, I couldn't find, it didn't have another spare board that had an R765. So I kind of put together this Frankenstein hodgepodge deal of 3 different resistors to reach the 33K. So with all this stuff replaced, you can see here that our diode is good. I tested the replacement Q708 in the component tester, checked perfect. So Q708 is good. R760 should be between 100 and 500 ohms, and if we test it, it reads, oh, hang on, 476, so that's fine. Now, R765, I had to do like a 3 resistor loop to get to 33K. It's a 15, a 15, and a 3. So 15K, 15K, and 3K, kind of in series there. And that gets me to 33K. Now, the original resistor that was in this position is only about a half watt or so. So having these bigger ones in here, that's fine. This is suitable, even though it's not pretty. It's about function, not prettiness or beauty. It's about function. So with those 3 together in there, I can go across that point, and we should have 33K. 32.54K. Perfect. And if we look here, I have to clean it up still, but this is the result of this. So R765 goes across here. R760 goes across the center pin there of Q708 to share this leg of 765, and the Zener diode goes across here, and then our Q708 goes through here. So this one's hooked to there, this one goes through. I repaired that whole pad and trace thing. We lifted off and showed you. I scraped off the solder mask and just did one big bridge across here. Doesn't look that great based off the angle, but it's more solid now. And then of course the center pin of the Q708, I bent over and touched the leg of R760. So that's all back together, and I think that is done now. So all we have to do is fix this corner that is destroyed, and we should be able and ready to turn it on and test it. So all the original, that's the 728 that I replaced, the burned up R765, this was 760. Yeah, the burned up R760, the bad R765 out of tolerance, the burned up Zener diode, the burned up and bad Q708, and the shorted U701. So that's what we've got so far. Now, let's fix this corner, and hopefully nothing else is faulty. Because when you short things out like that, you enter a rabbit hole of issues that hopefully don't cause you grief. So Alright, let's examine this. We shouldn't have to glue this back in place because it might just snap back to where it was. And if we try to... There you go, boom. There we have it. And I think we should... Well, this may be troublesome here. Let's go ahead and just kind of scrape all this off. Let's start with... And I don't normally use jumper wires or jumper leads. You've seen me fix stuff like this before if you've watched the videos. I don't normally use jumper wires or bodges. I just solder bridge everything over across each other. But with this, I'm going to have to use the jumper leads and everything because of the crack and where it's located on the board. I think that might work. That's all ground there. I realize you couldn't see there, but so this is all ground, and I can actually fix that real quick, like so. We don't want a lot of solder here because it has to screw down onto the... You can't even see what I'm doing, I'm sorry. It has to screw down onto the chassis here, but I think that should be okay for that. But let's try and move some of this over. Well, that might not work. So you've got this trace here. This is all neckboard stuff here for the video source, RGB. So we have this trace here runs up. Okay, so that's red. This trace here runs up across there to green. This one goes over here for blue. Then we have video ground. No. Ground goes up that way. That's fine. Actually, it might not be. I think that's cracked too, but we can just... That should work. Yeah, that's cracked across right there. This one here is not cracked. So we have 1, 2, 3, 4, 5. Oh, it's cracked across here. Right there. There's another one. 6. But this, I don't think this one here is cracked. Let's test it. So this runs to here, down through here, over to here and here. So that's fine. And then this one runs down through here. Yeah, it goes to there, but it's cracked because right there, nothing. So it's cracked right there and down through this way. So, all right, but this, that is secure. So the crack is now secure. Now we just need to grab some components here and do a little snipping. I got these cheap JEC crappy caps that we're going to just use here for this. And I'm going to tin all these tin all these up here so we can kind of see, because of the glare and everything, we'll get a little better view of what's going on here. I'm going to grab a little flux if I can here and just kind of trying to get this, there's not so much glare on here, but okay, that should work. Now we're going to need to just kind of that one's good, and we need to hold it in place while we bend this up, so we can do that. Then we'll bend it back down. Okay, let's check that one. That should run to here. Yep, so that's fixed. And it's solid. Alright, next one. Let's add a little bit more right down there. Same procedure. Bam, got it. Okay, now we'll hold this one flat while we bend this up. And let's check that one. That one runs to here. Got it. And one more. All right. Bend that up. And let's check that one. That one should run to here. Did my meter shut off? Nope. Let's... What in the world? It must be broken right there. Interesting. Well, okay. We'll just bridge it over. Or not. We'll have gravity to help us. There we go. Got it. Now, blue to there. Got it. Yeah. Okay, not pretty, but we're making progress. Now we've got the ground. Video ground runs around to here. That's good. Through this. Okay, now nothing goes to, well, this is sync, which is going to run up to there. That's fine. Then sync again here. Ground runs up to here, to there, so that's connected. Let's check this down to here and there. This one runs up and around to, this one runs up and around, down through this way, over to here. Oh, gotta fix that one still. Yes, we gotta, that's right through here. So, one last use of this cap, and see if we can make this work. Might have to do a little bending on this one. And actually, let's just cut it off right there and see if we can bend that down in place like so. And okay. Not the prettiest, but again, it's not a beauty contest. Okay. So now that should go from here to here. Well, it's still broken right there. I got to put a little bit more solder on that. Now I need another jumper. Well, another crappy cap to the rescue here. Okay, and try this again. This one's proving troublesome because it's broken in multiple spots. Okay, that is on there. Let's go to there. And let's tack that one on right there to there. Okie dokie. One last one here. Let's try this again. Right there to here. Hey, imagine that. Okay. All right. Well, let's try this again. So, I think it's red. Yes. Green. Yes. Blue. Yes. Ground. Yes. This is ground. It's going through here. It also runs up to here, and let's make sure that this isn't touching, and it's not. I don't want this wire to short out to the exposed piece there by that ground, but it's not touching. Okay, so that's good. Now we got this one runs down over to here, that's fine. This one runs to here, that's fine. So 1, 2, 3 ground, and this one. This one's ground also. This one was never broken. This one runs to there, which also runs to there. And I think that should do it. Let's clean this up real quick and we'll take another look. Okay. So, yeah, not anything award-winning, but will it work? Yeah, it's fine. You know, I'm not out to win any awards with this stuff, just for functionality and everything like that. So, all right, let's check and make sure we don't have any shorts here. Cross these two. Nope. These two. Nope. These two. Nope. 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 Okay. Nope, you can't even see. Sorry. Zoomed in too far. Nope. 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 Do these again. No, 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 no. Well, I think that will just about do it. Let me go ahead and reflow this resistor I talked about. Okay, this is kind of all mangled up, but that's normal. I showed that before, I think. Let's hit this real quick. Not sure why. I guess I should show that inside this thing is a refill cartridge. So if you buy one of these off of Amazon and the first cartridge goes out on you, don't throw it away, because there's a refill cartridge in the back of the thing, like a mechanical pencil. I want to get some of the oxidation off this B+ resistor, because it's not, the solder joint's not good on it. It's a little better, but okay, it's a big blob of solder, but that's fine. So I'm going to hit my horizontal yoke pins, my vertical yoke pins. All those are good, don't need to mess with those. And my W158, I think it was 9, yeah, the jumper for the power supply is hooked back up. Input header pins are reflowed. I think that's all I really need or want to do to this, and we'll go ahead and just power it up and see what it does. Now I have to get, of course, this back installed, so I need to go through and, well, I guess I'm gonna glue this in place, clean these these pins up, clean up these pins, put this back in, put it back together, put it on a tube, and we'll fire it up and see if it works. Fingers crossed, I hope so. Then I can cap it, finish up the reflow, we'll test it one more time, and call this done, hopefully. Hopefully nothing else is wrong. So let me get all that done, we'll come back and I'll be on the tube ready for testing, and we'll see how it goes. Okay, everything's back together, hooked back up. I got all the sockets and pins cleaned up and put back together for the video input header selection thing. We're set to the empty pins I talked about here for a medium res, and we're going to be using a TPG here just for some quick testing. If it all works, then we'll hook up an actual PCB, do some adjustments, see if we can make it look good. I have the meter set up here on our B+ test point to read our B+. Again, I put it to 119 with the light bulb. Should be somewhere around 117, hopefully, with this operates correctly. I got all the neck board reflowed and everything realigned and fixed with the color transistors. I got all the color pots cleaned and set to the middle position. I've mentioned before, on the K7400, K7500, the color pots like to be no higher than about 25% turned up. On the U2000, U5000, they like to be about 50%. So that's where they're set to. And everything, I had to borrow one of these standoffs here from another chassis, but everything should be ready for testing. I have the remote board here at the ready, and hopefully it turns on. We're looking to get around 117 for our B+, and nothing explodes. So here we go. 1, 2, 3. Nothing. B+ is good, but nothing. Our high voltage horizontal section is not functioning. I didn't see any smoke. Is anything hot? Nope. Nope. Let's move over to standard res. Maybe there's something wrong in the medium res circuit. I did not check Q703, which will keep it from turning on. I also did not check the horizontal drive transformer if it has an open winding or not, which I've never seen that happen on these series of chassis. But let's try, maybe the output will work on standard res. So let's try standard res here. So 1, 2, 3. No, we get a little click. And B+ is right at 123 because there's no load on the circuit. And so I'm going to turn it on again. Listen to the click here. I'm going to turn it on 1, 2, 3. There's a little click and the B+ turns on. Do I worry about just capping it? Oh, I also forgot to mention I did. Whoa, wait. There is some smoke here. Something is smoking. What is it? Ooh, yikes! Oh, that resistor I replaced there is hot. That one there. Whew. Man, I didn't check our B+ resistor either. This guy here. This is our B+ resistor right there. I didn't check that one. Wow. Okay, so there's no horizontal output. Oh, you can see my finger here where I touched that resistor. Ouch. I don't know what the rest... Oh, this is from the alcohol when I was cleaning the board. But this right here is from that resistor I just touched. Anyway, so yeah, we don't have any horizontal drive output because I think we probably have a problem with our B+ resistor or with cap possibly, but there's something on the horizontal circuit. I'm going to turn it back on. 1, 2, 3. And it's not smoking yet, but we did have some smoke. Well, regardless, I take it back out. Maybe the flyback is faulty. Maybe there's something wrong with the B+ resistor. Could have an issue with Q703. I'll do some poking around, see what I can figure out, but our horizontal section is not energizing. Whether it's any of those components, I don't know, but I'll poke around, see what I can figure out, and kind of come back and let you know. So stay tuned here just for a moment. Okay, well, this one's on me, and I apologize, because normally I check Q703, but I kind of got ahead of myself, a little overzealous in fixing all these other issues, and I didn't check Q703, and wouldn't you know, it's shorted. So Q703 is part of the horizontal drive circuit, and if you follow this resistor here at R728, this leg of R728 that was getting very hot and smoking runs right through our horizontal drive transformer. It goes through this capacitor, through a trace over here, straight to this leg of Q703, right to it. So with Q703 being shorted, it's overdriving this resistor, and it's just getting hot and burning up, and that's why the original one probably burned up. I replaced it and couldn't figure out what the problem was, and everything else went to hell. So you'll see here I have the Q703 in the tester already. If I hit start, diode. Both ways. That's not right. So I'll take it out of here and I'll put in a replacement. And by the way, Q703 Q703, Q708, and the K7000 Q10 are all the same transistor, C2482. So I stole this from another parts K7000 that I have. I got like half a dozen of them over in the closet. And if I put this one in here, ta-da, NPN transistor. So we now have, we had a shorted Q703 and a shorted and destroyed Q708. So wow, okay. Let me get this one installed here. Alright, and it's installed the correct way. It's not backwards or anything like that. And let's make sure it stays in there. And I'll bet you it'll work now, or at least do something different. Alright, so with that done, we will get it back on the tube one more time and try again for take two. Alright, so here we go for take two. Everything is reconnected just like it was before. We're set up to read our B plus again off our B plus test point, and we're still on standard res, how we left it last time. I did move the switch to standard res because I was going to test medium before, but we're not worried about this just yet until we have at least turn on and see what we get. So with the Q703 now replaced with a good one, let's see what we get for take two. Here we go. 1, 2, 3. Well, we got high voltage. And 115. And of course, would you expect anything less? Gosh dang it. Well, let's go ahead and turn the brightness down before we burn our tube up. Contrast, and let's turn down our screen pot. Okay. Would you expect anything different? Of course. But let's go ahead and adjust our B plus to 117 and, oh, wrong way. Okay, we'll do 117.0 because medium res will be a bit higher. But let's go ahead and turn it off, and we'll flip this over to medium res just to make sure that medium res also fires up. Yeah, I didn't think about it, but when this zapped to ground, it probably killed the vertical IC. We didn't check that either. So, oh man. All right, so now medium res is hooked up. Let's see what we get for this. 1, 2, 3. Yeah, it comes on. Oh, and that was right. I made a click, and we had 116-ish, and then it clicked and went to 130 something. Yeah, something. Now something's bad again. Let's go back to standard res and see what we get for standard. Does it come back on in standard? No. Did my thing come off? Nope. Now all we get is a click and we get nothing now. Did the resistor's not hot. Did Q708 or 703? This one, did it die again? All right, let's give it a second here. I'm going to discharge a little bit. Oh, my ground came off. My ground came off. Okay, that's what happened. All right. All right, here we go. 1, 2, 3. Yeah, there we go. Well, that was weird. Was my ground touching something? Might have been. But now we're back on standard res. Okay. Turn it off. Switch this over. Switch this over. I knocked my ground off when I swapped this, so let's make sure not to do that again. All right, 1, 2, 3. No. Medium res has an issue. Why wouldn't it? Let's put this back on standard and put this back on. Oh, this fell off here. Glue. You know what? Let's perform an experiment. Let's leave the wire hooked up and go back to medium. It's not supposed to be that way, but let's see. You can see right here, the wire should be hooked up for 15, and then the medium should have nothing. So with that being hooked up how it used to be, let's see what it does anything different here. No. Oh, well, my ground came off again. But it does this one little click and then goes to like a shutdown type of thing. So we'll leave that on standard. Put this back. Okay, here we go. 1, 2, 3. Standard res works. 117. And we get our line. So I guess we'll tackle one thing at a time. Let's fix our vertical collapse, and then we'll worry about our medium res issue. Well, I figured out the problem, or pretty sure I figured it out, because we were missing our 26-volt reference at the vertical IC, which I'll show shortly. But the way the circuit works is the flyback will output 26 volts DC through R303, and then it runs through C302, which then runs down through D302, which then runs over through a resistor or two over here, which never go bad, and it goes through D603 over here, and D603 should only read in one direction. Negative lead down this way, positive lead that way on D603, so you get your 0.5 voltage drop. If you swap your leads, it should read open. It should not have a reading. If it has a reading both directions, the vertical IC is bad. Well, we didn't have a reading both ways, so I knew the IC was okay. So then we go through the vertical IC and verify that none of the pins read to ground that shouldn't. There should only be one pin that reads to ground. And if we go to continuity mode and we go to ground, it should be that was a cap that discharged. So nothing, 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 nothing. This should be our ground. Yep. And nothing, 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 nothing. So the vertical IC isn't reading shorted. And we're not getting any indications of it being shorted or bad because D603 only read in one direction. So with the IC checking okay, and D603, D302, R303, and C302, a little film cap in there, all that checked okay. Those are the major components in the vertical circuit. All that checked okay. I started scratching my head and testing around, and it turns out that in all of my overzealousness, I forgot or overlooked to fix the little crack down here. So if we go down here and look, we fixed this one, this one, this one, this one, but I didn't fix that one. I'm sure there were some people screaming at the screen, hey, you forgot one, you forgot one. Well, you're right. I forgot it. I didn't see it, overlooked it, didn't occur to me to even check this. I thought I fixed all the ground here. But this trace, if you actually follow this trace along here, guess what it goes to? It goes around here and goes directly to here. This trace runs along the edge all the way down here, and it runs directly over this way to one leg of C302. So C302 is part of our 26-volt reference circuit off the flyback. So C302, the 26-volt reference, was not getting to our vertical circuit because it was not in the circuit. That's what this bottom trace runs to, and it runs directly over here to this test point, which, guess what, is our part of our resolution circuitry pin there, right there. So that's why that is why the medium res side of things was freaking out, because the resolution pin here was missing, out of circuit, because of that crack that I didn't fix. Then that 26-volt reference also goes to here, which jumpers across this back to our vertical IC. So with this crack being not repaired, we are missing our 26-volt reference. There's 26 volts, I think, on this pin. I think this pin, and this pin, I could be wrong, all get 26 volts, and they were all missing 26 volts. After fixing this crack here, the 26 volts is back. So that should solve that one broken trace here that I didn't fix the first time around. That should solve all of our problems. So I'm going to get this back on the tube one last time, and hopefully the third time will be the charm. Let's see. All right, everything hooked back up for a third time, ready for testing now with the corrected missing or broken trace for the resolution header there. Got that fixed up, so hopefully now it does work. at least. So let's see here. 1, 2, 3. All right. It does fire up. Let's go ahead and make sure we don't have any collapse. Nope. And hey! Turn our TPG on and adjust our H hold. Well, that's weird. Why is the screen completely blue? I think our blue transistor is shorted. Let's adjust our blue here. Okay, so if I turn the blue down, or at least I get that, H hold. Oh, great. We've got bad components here still, because this is... I only have blue. We only have blue. There's no red, and there's no green, and we have oscillation problems. Would you have believed it? Yep. Right there is where our stable image should be. And there is some other bad component in this circuit, and I am confident that it's probably going to be one of these film caps. So, oh look, now we got green. Green magically came back on its own. Still have no red. Red does oh, now we got red. What in the world? Oh, bad pots. I cleaned the pots, but apparently still, yeah. Oh, if I turn contrast down, red and blue go away completely. Okay, well, green's being overdriven, that's why. Let's turn green down here. Okay, that's better. Turn contrast down. Now they all go away, okay. Well, I've got RGB now for messing with the pots, but we got horizontal oscillation problems now too. I mean, it never ends. So this is a brand new U701. I know it's not that. Well, we're at 116.8. B plus is fine. Let's turn this off. And we'll flip this off, go to medium, turn it back on. And let's make sure our medium res is working. I bet it is now. Okay, and then we have to move this over to the non-wire selection. There we go. Okay, let's see what we get now with medium res. Hopefully this is resolved. If not, we got more issues to solve. So here we go, 1, 2, 3. Nope. Medium res is still jacked. It tries to, it just immediately goes into shutdown. We might simply just need to adjust our shutdown pod, but I don't think so. Well, let's tackle one thing at a time. I'm going to put this back on standard res and then try and do some testing around here and see if I can figure out what component is faulty causing our oscillation problem and come back and try attempt number 4. Okay, so I did some poking around and testing off camera and I couldn't find anything wrong. But what's odd is that, well, let me go back. I ended up changing out this C703. This original cap here, this blue one that was burned up, I was doing some testing and moving components around and it finally gave up the ghost. The leg came out of it, so I had to replace it. But this wasn't the cause of our problem. You can see here I have a replacement right there. It's a kind of a yellow one now. But anyway, that wasn't our problem. I noticed that poking around here doing this testing and using a U5000 as a test platform, if we actually measured across C703, we get 7.51 megohm. On the U2000, we're getting 11K. This circuit that burned up here across this resistor, I think it was at 713, whatever it was, it runs around this way through a couple jumpers, ends up right down here at the remote board harness, which runs directly to the H position pot on our remote board. So when you read across here, we're getting 7.5 megohm, and on a working chassis, it's 11K or so. So it actually runs, this whole circuit that burned up runs through the, I mentioned before, it runs around through this way, through a couple of jumpers, and right to the remote board harness, which ends up back over here directly on the H position pot. You can ring directly from the meter, directly from the pot right to the C703 and this resistor, and then off to U701. So what I found was our H position pot is completely open. If we read across it, I get no reading whatsoever, completely open. This shares the same trace, 0.2. If we go to H position, nothing. Now, part of the issue is I think this was working in somewhat half of a capacity, and the H position might have been shifted over. If the H position is shifted too far left or too far right, sometimes you get the oscillation problem. So I'm confident that the original oscillation problem wasn't anything in the circuit like I thought it was, because I went through and tested everything, couldn't find anything wrong. I think the oscillation problem was the fact that our H position was slid over too far one way or the other. But in trying to adjust this, the HOT shorted. So I think what happened was this pot is bad, and it was barely making a connection, and it was shifted too far right, causing our oscillation problem. When I tried to adjust it, boom, it opened up completely and took out the HOT. So now I got to change HOT out. But if you see here, if this trace here is connected to each other, so it's always going to be 0. But if I actually, like, let's say for the horizontal size, I can actually go to the horizontal size here and touch these 2 points, and you'll see that it's 2.9K, and I can adjust this. See, there's 2 ohms, 3.5, 4.4, 5.1, so on and so forth. If I do the same thing to the H position pot, it's completely open. No reading whatsoever. If I turn the pot, I get nothing. The pot is open. I've never seen one of these pots fail like that. So our problem, I'm 99% sure of the oscillation, is the H position is too far one way or the other. That's a known issue. I didn't think about it at the time, but off camera when I was doing testing, I tried to adjust it and it shorted the HOT. So now it's just ticking, tick, tick, tick. So now I have to replace the darn HOT also. You can see here, if I put this in diode mode and I go to the HOT, it is now shorted. So let me change this HOT out, and I will replace this H position pot. As a matter of fact, let's go ahead and just take it out completely. I've never seen one of these fail, and it's quite possible that it burned itself up internally, because like I say, this connects through C302 and this R713, I think it was, directly to the H position pot, directly to it. So it's possible that it burned up the contacts inside the pot, and part of that problem. So now we have this as an issue to add to the parts pile. Let me take that out, and I gotta find, what size is this? This is 20K. I gotta find a 20K pot, put in there. I gotta change HOT out. When I come back, we'll have this back on the tube ready to test for the last time, hopefully. I think I left off with the second attempt. Off camera I did a third attempt, and that's when this all happened. So I think we'll come back for attempt number 4, and we'll see if that works. All right, so here we are with 4th time. Hopefully 4th time's the charm. Again, I mentioned I got that C703 replaced, or because the other one broke the leg, even though it was fine. I got the new FJL6920 HOT installed, or a new FJL6920. So that's good. We're set up to read our B plus again, so hopefully it turns on this time. It doesn't short the HOT. I did not have a 20K ohm H position pot, but I had 25. So I went ahead, it should work. So I went ahead and measured a U5000 I have that's working, and adjusted it to the same position that pot's in on the U5000, so that should be okay. I'll turn the TPG on. And now, hopefully, this will work in both standard res and medium, because I'm thinking maybe with the H position pot being shoved up too far over, it was going into shutdown on medium res. So hopefully a medium res will work now too. So only one way to find out. Let's turn this on and see what we get. 1, 2, 3. Oh, jeez. Forgot power. I did check everything else. It's all hooked up. I forgot power. Let's try again. 1, 2, 3. Yes. And we get 117 pretty much on the nose. And I don't hear any odd noises. There you go. So H position pot open was causing oscillation problems. Let's move it now this way. And we're way too wide here. Let's go there. And let's do width. Where's that at? Over here? Nope. Width is this one. Okay, good width control. H position, we'll move to there. Vertical size is good. Vertical position, bit scratchy, but that's fine. Move our height a little bit more. And I dare say that's good. Looks like I got a horizontal linearity issue. See how it's too far that way? This should be in the center and it's off to the side. We may need to take that back apart and flip that magnet around the other way, but let's hold off on that for now. All right, so let's go through, make sure we have RGB. Yes, but it's way too intense. So I guess what we'll do is we'll turn this down to roughly 25%. Maybe there's something going on with, something's very wrong here. Let me get the camera on the tripod and make some adjustments here. Hang on. Well, I just want to show something here real quick. I was messing around with some stuff, and you can see here now that our linearity is basically perfect. See how it's dead center now? It's dead center. And we have the edge of our raster here, the edge of our raster here, and the middle of the image is dead center. Now that's with an additional little magnet on top of the linearity coil. If I take this little magnet off the top, it's just resting on there. You can see it's a little magnet that sits on top of there. Now our linearity is slightly off because it's wider on this side than it is on that side, and it's shifted over to the left. You can see that we now no longer have the edge of our raster over here. It's shifted off to the left. If I move it off to the right to match it up, then our center line is now too far to the right. If I take this and put it back on here, you'll see here, I'll just take this and set it on top of the linearity coil there. And as I do that, watch the edge here. There you go, see that? All I'm doing is taking this magnet and putting it on. As I do this here, you can kind of maybe see that. So if I put that magnet back on top of that linearity coil, it is now dead center in the middle. And we get our edge of our image and the edge of our image. So I'm probably going to have to add that magnet to the top of this and glue it in place, because that's how it's going to have to be. And if I scroll back through here, oh man, let's turn our contrast down. Right there. That's not bad. And if we scroll back through, RGB is good. I was messing with the color pots and got it all adjusted. So now what I want to do is turn it off. And I want to swap this over to medium res, and I'm hoping that this should work now, for the simple fact that it wasn't working before, because I think the H position was way too far off. It was going right into shutdown. So turn this off, medium res back on, and fingers crossed, medium res now works, and we can kind of finish this thing up. So here we go, 1, 2, 3. Yes, and we're even at good B+. So yes, medium res wasn't working. Whoa, well, wait a minute. Freaking course not. No, that's as wide as it gets. I can't win. H position. Yeah, I mean, it's working. We got a good image. The B plus will change depending on what's on the screen. See, 16.5. So B plus is fine on both medium and standard, but this is what we get. I mean, if I can fill the screen vertically, but the horizontal size, that's all we get. So there's something wrong with the width cap. Maybe somebody changed out the width cap. That's this one here. I'll bet you that's what happened. So I'm gonna have to go through and see what the original width cap is supposed to be and change the width cap out, because I think the only thing wrong with this is the width cap is not right. How's our linearity? Linearity is somewhat okay. It's off to the left, but yeah, I need to fix that. So I'm going to change out that the width cap, which is this one here. For medium res, it's this one. For standard res, it's that one there. So standard res width cap, medium res width cap. Let me get that changed out and see if that gives us our full width. All right, so it's been about an hour and a half. I did a complete full cap kit, a complete full reflow. The chassis is now completely rebuilt. All the repairs and everything that we did. I also added a couple of heat sinks to the main heat sink there, because the U5000 runs really hot compared to the 7400, 7500. The 7400, 7500 has a much taller heat sink. This one has the tiny one, like the U2000. Some U2000s run cool, other ones run real hot. So the U5000 and the U2000s that run hot, I put these additional heat sinks on here that really help dissipate the heat. Really makes it much better. So it turns out that the cause of our width problem, so if you recall a few moments ago, for me it's been a couple hours, for you just a few moments, but if you recall, the width on our medium res setting did not have complete full width control. That turned out to be bad caps. I did a full cap kit and we've got full screen now. So everything else that was wrong with this was bad caps. Yeah, it seems to work and look right. I just spent some time. Brightness is a bit too high. Let's turn that down slightly there. That's better. I went through and spent some time doing color adjustments and everything, and it looks and works great. It's a bit too green right now, actually. I'm going to turn the green down. I had to replace the green pot because, oh, wrong way. It was just too scratchy. That's better. Nice. Okay. Yep. Not perfect, but good as it is. And I think our linearity problem is even solved because it's somewhat. I took that magnet back off. Here's that magnet. Took that magnet back off, and it's just back to the way it was. So, yeah, all the work is now done. I think the remaining issues we had with this were just bad caps, and the full cap kit fixed it. And as you can see, it looks and works great. So I'm not sure if our linearity problem is solved or not. It's somewhat close, but you can see now that our major issue of the medium res not being able to fit full screen, that was absolutely bad caps. There were a couple that were kind of bulging at the bottom and a couple that were bulging at the top. They weren't bulging upward, but you could see they had expanded because the plastic around the top was gone. So at that point, you know that the bottom is kind of expanded. So there were a couple of caps that were like that. But overall, I think we now have a fully functional U5000. So there's medium res, perfect, no issues. I'm going to turn it off. I'm going to swap this connector over to standard res. And now I'm going to swap this connector over to the white wire. And I'm going to swap the board out for Mortal Kombat 2. And I've just got my boards sitting up here. And we'll grab this MK4, MK1, MK2. And we'll plug in our MK2. And we're going to have to readjust all of our screen size, position, shape. I'm trying to do this one-handed here. And it doesn't really ever work out properly. I gotta put you down. Hang on 1 second here. Oh, stay there, you. There we go. Okay. So now MK2 is connected. So let's turn this on. 1, 2, 3. Okay, you don't hear the high voltage because the U5000 doesn't discharge between power cycles like the other ones do. The K7400, 7500, and the U2000, I think, will discharge upon power cycle, but the U5000 must be manually discharged. It's kind of counterintuitive, but the U5000 doesn't auto discharge, so you always got to manually discharge your high voltage. But hey, it's working. Let's do H position, shove it over. Yeah, I think our linearity is even resolved. Let's turn our height down. Yeah, maybe. Brightness right about there, contrast up. Hey, looking good, boys and girls. Fantastic. Yes. Okay, let's start a game here. And we'll select a character, Liu Kang. Let's make sure the timer is somewhat centered. Well, no, linearity is still way off. That's the center of the tube, and you can see the timer is about an inch too far to the right. Now, I don't really want to put that, permanently affix that magnet to the top of the linearity coil because I don't think it's actually supposed to be there. I have this issue on all the U5000s that I use to test on this tube. This is a dedicated U5000 tube. You see there, Wells Gardner monitors 25-inch 5.0 for 5000, but I have this problem on all the U5000s I work on. They all have this problem. I think the last one I did, I used a magnet and sent it back to the person that owned it, and I never heard back. But I don't think I actually should leave this on there because it didn't have it on there previously from the factory, and I think this is an affect of something with this setup that I've got going. I'm not sure, but I'll attach that back. So I'm not really too worried about it. If the owner of this gets it and has a linearity problem on his end, he knows how to fix it. Get a little magnet, put it on top of the linearity coil, and that'll move it over. But as far as the repair goes, we are golden. It looks great. So, yep, there's all our pile of bad parts. We have that's the green color pot on the neck board that I had to replace. That there was the bad H position pot. HOT got taken out. The U701 got taken out. Replaced that R728, I think it was. Oh, and there was a capacitor. While I was doing the recap, there was a capacitor, that one right there by the B plus pot. It was broken for some reason. It had a whole side here that was, yeah, right there. It had a whole side chunk broken out of it. So, yeah. And various other things, two bad C2482 transistors, the burned up R760, R765, the Zener diode that was in bad shape, all that jazz. So with all that fixed, we seem to have lost green. Is that my wiring harness? Nope. I may have spoken too soon, so that one's definitely hot. That one's definitely hot. That one is definitely hot. Now I've lost green. It never ends. I was making an outro here. And you got to do this to me? Yep, we definitely lost green. No doubt about it. Come on. Well, now I'm probably going to have to change out that transistor. Because when we first turned it on, if you recall, we had all green. And then I was adjusting. I thought that maybe that pot was good. Maybe the scratchy pot I thought was the cause that I changed out. Might have just been something with resistor's warm. The heatsink is warm. I've lost green. It's not an issue with my harness. I know that. It's not something with our repair because it was working. Let me try and get this green thing solved and then finally get this. I thought I was done. That never ends. Let me get the green resolved and I'll come right back. All right, so I got the green back, but not through any type of repair procedure. So let me show you guys a trick here. So if you're ever missing a color, completely missing a color, you can short out the the base of the transistor, I forget, but you'll see here that this is not conductive. If I touch this, I've got one lead on ground, other lead I'm tapping this, and you can see it doesn't really make any difference to the screen. But if I go to this top part of the leg of the resistor, I can just tap it and all blue. I go to the red, all red. I go to the green, all green. So all I did was I tapped all three of those. All I did was just tap the top of that resistor leg like this. And one more time right there like that. And the green came right back. So I think we have a resistor that's sticking or failing. So I'm going to change that green resistor and call it good. So green came right back. So it's not anything with our repair or anything I was just worried about. But yeah, so that green transistor must be like on its last leg where when it heats up, it turns back off, or who knows what's happening. But grounding out the base, I believe it is, and forcing it into a short, basically, brought it back. So that's one trick you can do. If you're completely missing red, completely missing green, completely missing blue, on really any chassis, you can ground well, like if you were to imagine there's no heat sink on here, imagine there's no heat sink on here at all, and the back of the transistor is exposed, that's what you would short. And that happens to be connected to the top leg of these three resistors. So if I just touch the top leg of that resistor with the red, or blue, this is blue, you get all blue. If I do it with the red right here, you get all red. And if you do it to green, we get all green. So that's one way to verify that the transistors aren't open. So if you're missing a color, you can do that to verify the transistor isn't open. But I think what's happening is that that green transistor is starting to fail. So I'm going to change it out as a last resort. I'm not going to do it on camera, but I'll change that out, make sure it's working, and call this done. Altogether, I think this is sitting at about 6.5 hours worth of troubleshooting and repair. It may seem like I don't spend a lot of time on these, but this is Saturday morning. I started about 8:30. It's now 2:30. So, you know, it takes a while to get through these and go through stuff. And I film everything that's important and you need to know, but there's a lot of it I don't film. So anyway, everything is now resolved. This thing was exploded in more than one place, but we got it, tackled it, as difficult as it was, and we're now working and operating. So thanks very much for watching. Make sure you like, share, and subscribe. Comment down below what you thought, and I appreciate it, and we will see you next time. Boom, 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 boom,